So we're going to go over how programs work. This is our worksheet 0. It's a long story why it's 0. Anyway, all right. How a program works. All programs have 3 key components. This overall diagram is a very basic sketch of a program. A program takes some kind of input, processes that input, and then generates some kind of output. What's an app that you use on your phone a lot? Snapchat. Okay, what kind of input does Snapchat take? You're typing in text. You're taking a picture on your camera. What kind of processing does it do? You might select other options to apply filters, but it packages all that up, and you've selected who to send it to or what to post it to, and then its output, for you, the output might be Snapchat sent. Okay? The output for others, they might be just sitting there and all of a sudden their phone lights up. And so they've received an indication. They hit an input saying, show me. It processes, reads it from the Snapchat servers, and output displays said image, video, message. Here you go. And then shortly thereafter, the shredder starts and deletes everything, right? Something like that, right? It always disappears. No one ever can see it again, right? No, it's always saved. If it's not saved on your phone, it's saved on the servers. Everything you do. Okay, what's another example of an app used on the computer? Chrome. What kind of input does Chrome take? You type, you click with the mouse. Chrome actually takes input from the internet. It's reading stuff from the internet. Processing. It reads what you typed and what it read from the internet and displays. It can print. It can play sounds. It can play video. Those are all output kinds of things. Visual Studio. Let's talk about Visual Studio for a second. Visual Studio input, you have keyboard, you have typing, you have the files that you previously saved. The processing that Visual Studio does are things like compiling and debugging and displaying. That's kind of the processing that it does. The output that it does, I jumped up ahead a little bit. The output that it does is it will create an executable file, your program. It also displays things on the screen. It displays your code. It allows you to select different options and properties and things like that to adjust how your program is put together. Does that kind of make sense? Every program has these 3 primary elements. Some kind of input, some kind of output, and some kind of processing. Sometimes the processing is very minimal. Sometimes the processing is really heavy duty. I mean, applying like Photoshop, if you're using Photoshop, Photoshop does some really advanced algorithms to adjust, merge images, colorize things, and so on and so forth, blend, apply patterns, tools, brushes, stuff like that. Does this make sense? Everybody got the first half of the page done? You should be through question 1 and 2 with all the necessary information. If you're not, you're asleep. I see every head is up, but you still might be asleep. Okay. Where do we save projects? We're going to talk about this, and it's perfect. By default, when we did Draw a House, it saved the project on your C drive, on the local hard drive. As discussed previously, that's the worst place to save it because You don't have this computer at home, part one. Part two is that our computer tech can come through and wipe out all the computers and all the files on all the computers at any time without warning. He's not going to check with you. He's not going to check with me because he might be having a problem with computer 13 and he says, I'm just going to re-image it. So he wipes it clean and puts down a fresh copy of Windows and all the apps. So local hard drives, not a good place. Flash drive. Flash drive is a really good place because it's portable. You can take it home. It doesn't get wiped out by the computer tech. What's bad about a flash drive? You can lose them, you can flush them, it can be easily stolen. Dog can eat your homework. Get it wet, drop it in a drink, whatever. There's also this student drive on the network. Not really a good place because you can't get to it from home. So I wouldn't recommend it. There's also cloud-based storage. Cloud-based storage are things like Google Drive or OneDrive or Dropbox, or there's a whole host, iCloud, whole host of other cloud-based storage. That one's okay. Not the best place. Not the easiest to always get to. But you can. So don't save it to the local hard drive. That's the worst place. All these other places are far better. Flash drive is the best. Any question on saving projects? That was the answer to question number 4. Okay. For all of our assignments, we're going to be doing this thing that's called event-based programming. All of our assignments are going to be built of 3 primary controls or building blocks that make up what we do. There's a lot more than this, but we're keeping things straightforward and simple. We'll be using a button, text block, and text box. I wish these were named slightly differently because they're text block and text box gets confusing for you when you're brand new to this. You know what a button is. You've seen buttons on Windows. You've seen buttons in your apps. You click on a button and you're usually triggering something. You're triggering something to close the app. You're clicking on a button to start the game. You're clicking on a button to send your email. Buttons look a lot. Links on web pages are similar to buttons in many cases. A text block does one thing. It displays text. A text block displays text. That's all its life is meant to do. It's a read-only piece of text. A button can display text inside the button. You can put a whole bunch of text inside there, but usually the text inside the button is telling you what's going to happen if you click on this button. You're clicking cancel. You're clicking OK. You're clicking start or go or something like that. So a text block, just think of it as it's a way of displaying text. Text box is a place for typing in text. So if they ask you for your username and password, those boxes where you type those are text boxes. These 3 components will make up pretty much everything that we do in all of our assignments. And learning how to control and interact with them will be key to building all of our assigned homework. Now, a text box can kind of behave like a text block in that a text box can be used to display text. You can make it so it's read-only so they can't type anything in there. A text box also has the ability to scroll text. So there's some similarities between the two, but if you just kind of stay to the primary reasons for these: button, triggering an action; text block, display text; text box, to take input. So a text block is primarily an output control. A text box is primarily an input control. A button is primarily an input control. Just thinking of the computer, the program, input, output, processing. A button often is the thing that triggers the processing to happen. So here's an example of an extremely simple application. It looks like it's asking you to type a player name. It looks like it's displaying a current score, and it has two buttons, shoot and close. So this is a text block. It's used for just displaying text. This is a text block. It's used for displaying text. This is a text box. Usually the text box has this outline, and you can click in it and start typing. Obviously, these are two buttons. So we've already kind of gone through these text blocks, buttons, and a text box. Now our programming style with C# and what we're going to be using is called Windows Presentation Foundation, also known as WPF. It's event-based programming, meaning when you click on a button, it triggers an event. And you wire this button so that when you click this button, it's going to go run this piece of code. When you click this button, it's going to go run a different piece of code. And that's important for the processing part of our program. There are also other events that take place naturally through the course of the application running. In the Draw House example, we wired code up to the paint event. The paint event is whenever we want to display something in the window, we'll go run that piece of code. There's also events for when the program starts, go run this piece of code. There's when I'm clicked, go run this piece of code, or go run this other piece of code when that button is clicked. So you're going to see how all of this comes together on our first assignment, which is the calculator assignment. There are also things with buttons. When you've noticed that when you put your mouse over a button, let me show you the example here. See, when I put my mouse, I'm just waving my mouse over the button, choose wisely. And notice how it changes changes color slightly when I go over it and come off of it. That's an event. There's an event called mouse enter, if you will. When your mouse enters the region that is this control, it says, is there any code for me to run? When it hits mouse enter, it says, yeah, change the background to a lighter hue of blue. And then there's also mouse leave event, that when the mouse leaves that control, it automatically calls that control and says, oh yeah, go back to our default gray. So there's mouse leave and mouse enter. We're screaming along. This is great. All right. Did anybody not finish the worksheet along the way? Everybody got the worksheet done? Excellent. I'm going to stop the video.